Good morning, good afternoon, good evening, everyone, wherever you are in the world, in our virtual world. Today, we're going to be talking about men from Mars, women from Venus. Both can code .NET in Jupyter. My name is Ron Dagdag. You can contact me through Twitter at Ron Dagdag. And let me give you a back story why I chose the title for this presentation. My wife and I were both a software engineer. I've been a .NET developer since 2005. My wife Leodette, she's been a developer since 2003. We both started early in .NET Framework. She started .NET Framework 1.0 and I started in 2005 using .NET Framework 2.0. These days, I've been doing a lot of .NET for doing AR and IoT application using .NET Core. I work for a startup. That means I'm building a brand new software. On the other hand, my wife has been into maintaining large enterprise application, doing .NET Framework, and of course software that makes lots of money. And as I see the contrast between the two, I know we both live in that same .NET solar system, but we feel like we both live in two different worlds. And then we kept hearing about this other world out there, in the world of Jupyter and data science. And I heard that a lot of Pythonistas live there. The reason I say that, Pythonistas is a word. They have a mug. So today, I will be talking about what is Jupyter Notebooks, related to how it relates to .NET Interactive, the .NET Jupyter Notebooks. I will demo it in a Raspberry Pi today, and hopefully at some point we land in Mars and Jupyter. In Jupyter, I mean. So Jupyter is an open source web application. The start started back in 2015. It used to be called IPython Notebooks. And its goal is to create and share documents that contain live equations, live code equations, visualizations, and narrative text. The word Jupyter came from the first few kernels that got started at Julia, Python, and R, and that's why, it's a combination of those words, and it's released under modified BSD license. .NET Interactive is another project that is open source on GitHub that add .NET into interactive experiences, just like Jupyter Interact or Visual Studio Code. It allows us to share and explore and write different applications into these different apps. So in .NET and Jupyter Notebooks, you'll hear more about kernels. Kernels are the application that runs in the server, where you have a Python kernel or an R kernel. With the .NET Interactive, it adds C#, F#, and then PowerShell. So Jupyter has lots of kernels that it can run, but the .NET Interactive adds that capability. There's also magic commands that you can use, and I'll demo this later on. That tells you more of what its capabilities, and then the pocket view, which allows us to display HTML and XPlot library, be able to print and create charts. Azure Data Studio, if you haven't looked into it, I would recommend. It is actually on GitHub. It's kind of like the SQL Management Studio. But this one, it relates to where you can, you can create Jupyter Notebooks inside Azure Data Studio. And with .NET Interactive, it allows us to have that capability too, where you have C# and F# and PowerShell. I mean, I can, and it is on GitHub. It looks something like this when you run it, but see how it, where you can create, new notebook. So when you create a new notebook, it would look something like this, and you will have like a list of kernels that you can connect to. So, the .NET Interactive adds that capability where you can have PowerShell, so you can write, C# code, and when you click on this, run this cell, it would execute and it would give you the result right below it. If you want to add another set, right, another code cell, you can, and C console write line, right, hi, and then I can press F5 and it would return back. And the good thing is you can save it as a notebook, but you see the difference, right? You can run the code and get the results. So it acts like a document with code and the result all in one. Let's go back to the presentation. So this would be useful if you have like PowerShell commands that you want to document, whenever you're, or Azure CLI commands that you want to, after a few months or a few years, and you want to remember, okay, what, kind of gives you a clue, gives you a document, in a way documents what you did, and the results. So before you rerun that command, you have an idea of what it's gonna do. So it helps not just yourself to document those commands, but also another person in your team. Visual Studio Code also has a way to have Jupyter Notebooks. There is a .NET Interactive Notebook extension that you can use to create a .NET Interactive, so you can have Jupyter Notebooks in it. There's also the way you can, I think there's a .NET Interactive Notebook, which has an extension of DIB. I haven't really played with this part, but I'm more interested in running notebooks inside Visual Studio Code and Jupyter Notebooks. So how it runs in the back end. So the kernel, which is, if you have a C#, F# kernel, it creates an instance of your program in the back end as an execution language. And so it allows us to be able to have different types, but and these are the different applications that you can do the interact. So one of them is Jupyter, and it passes that information to the kernel, executes that command, and then returns the results back and forth. So that's how it allows us to be able to have all these different applications. So it's not just limited to Jupyter, but also Visual Studio Code, Spark.net. We talked about Azure Data Studio. Actually, there's Teams. You can also have a bot with the C# kernel in the backend that you're chatting to. And I found out the other day, Cosmos DB has a way to create this notebooks too. Raspberry Pi, if you haven't heard of it, it's a Linux device, right? It's an ARM processor. It's not just Linux that you can install it. There's a Windows IoT core that you can install on the Raspberry Pi, but it is a computer, treated as a computer that you can add sensors. and it has connection to the Wi-Fi. It has HDMI, and this is the Raspberry Pi 4. And what I did with the Raspberry Pi, I installed these Sense hat that adds different sensors to the Raspberry Pi. In this case, I'm interested in how I would use the these LED matrix over here, and also the temperature sensor on that. So to install Raspberry Pi, this project, this program that I've created a shell script that you can install that has Jupyter Notebook, that installs .NET Core, installs Jupyter Notebook, and also the .NET Interactive into Raspberry Pi. And then after it installs that, now you can go to the browser and sign in to Jupyter Lab, which I will demo next. In order to enable the Raspberry Pi Sense hat, there's a few steps that is needed in order to enable that to be able to be programmed inside Raspberry Pi. So there's lots of instructions out there, and I have the link there too. If you're interested in getting a copy of the project I would be demoing today, it is on my GitHub page, and you can download it there. And I will post the link later on at the end of my presentation. Or there you go. You can actually get it on my GitHub page. So let's go to the demo real quick. So this is the Jupyter Lab. Each one of these tabs is a notebook, right? And it's a collection of Jupyter Lab allows us to be able to kind of look at the files, look at the kernel sessions that is available out there. The cool thing is this is the IP address of my Raspberry Pi, which is right here beside me running. And I can actually, instead of SSH or connecting to that device, I can use Jupyter Lab to be able to connect to my device from here, right? So I have my files there, and I have this Python notebook. In order to create a Python notebook, you can do File, New, and of course Notebook. And then the first question it will ask is, what is the kernel do you want to create, right? And of course, the preferred one is Python. A lot of developers have been using Python, but you can do C#, F#, and PowerShell on it. So there are two, when you create a new cell, right? You can either specify it's going to be a code or a markdown. So like this thing right here, it is a markdown, and I specify there hello world, and it would shift enter would render that. So the same way you can have, like in this case, a different text, also links. So let's try to run it. I would specify, hey, my kernel is C#, and this is start terminating. Okay, let's go back here. So if you want to restart that kernel, you can actually shut it down here, and then now it's specified, hey, the kernel is not there. I can specify, okay, we're going to start over and we're going to make sure that it's a C sharp. So all my code here would be C sharp by default. So this ls magic, kind of displays what are the things I can do. I can have on this .NET kernel, I can specify C sharp code, F sharp code. I can do a PowerShell. I was surprised. I didn't know that you can actually run PowerShell in a Raspberry Pi now on Linux box, right? PowerShell runs on Linux on an ARM processor. I thought that was very interesting. And so you can also run JavaScript, HTML, and some of these commands. So like in this case, if I want to, by default, all my code that is on here is C sharp, but I want to do F sharp, so I can specify that F sharp, and then I can write my F sharp code. And of course I can click this play button to run that cell, or shift enter, and you see the number right here. That means it executed, it was done, and it's the second command that I did run. So if I run it again, it's going to be 3. It increments every time you run. So, and the result goes right here. And if I want to grab or share that variables that I did run on my F sharp program to my C sharp kernel, right? I can specify here, export or share that variable and print it out. So you can print it out by just writing the variable name. So like, let's say I did not share Y, and if I run this, it should error out, and it kind of tells me, hey, there's a compilation error. So it feels, if you think about it, it's kind of like a CLI command, right? You execute one command at a time, and it gives you the result. So that makes it that .NET interactive activity. So if I want x plus 1, I can specify this, and if I want to change it to x plus 2, I can run it again. Now there's a different result. This WOS, whos, list you all the shared variables. It's like in this case, what type of that shared variable is, and displays it. Okay, so this one, PowerShell, I can run my PowerShell commands from here too. And it lists all the commands I can run in PowerShell in Linux. Okay, so we'll start programming in C# from this point forward. I have a nuget package. This is how you would import a nuget package. In this case, I want to import 3 nuget packages. The system device GPIO, which allows me to be able to access the GPIO from my Raspberry Pi. This IoT device bindings. So what I'm doing here is this IoT device binding has the sense hat library that I can use in .NET. So we'll import that one. So there's a lot of libraries out there for C# or for .NET IoT. So C# .NET IoT GitHub, I believe, would kind of give you the repo. So it is open source if you want to download that. So it's not loading. Oh, there you go. So this device bindings, there's a lot of documentations here. I believe that you'll be able to look at the different device bindings and what are the available connections that you can use. So this one allows me to be able to create an href tag that when I click on it, it has inside the span, and I can display it here. And so it's an href. When you click on it, it opens up the link, and so this is the link to my presentation. This one I added pragma warning disable because it was getting an error every time I run it. Without that, it would give me the error that something about abstraction. It's not an error, it's just a warning. So this one, hides that warning. So if I want to create an HTML tag that has the word sensor data, color blue, and display it, I can do that. So remember we did a nuget package for the IoT device bindings. This allows me to use this iot.device.sensehat that is available on that .NET IoT on GitHub. This allows me to be able to easily read sensehat data, where I can just specify to get me the sensor, the temperature sensor on it, the data from the temperature sensor, and display. And then here I'm using this, I'm adding, every time I read the temperature data, I would update this HTML right here, this sensor data right here, to the current temperature, and then loop back again as I add it to my temperature list. So when we want to call that, see, read temperature, I want to specify, okay, well, let's read it 10 times, see what happens. See how it's changing that. It changed it to green, and it's modifying that part, and as it grabs the values. So I'm importing this xplot. This one allows us to be able to view what is on the temperature. So I just want to show you that I can use the link commands. So now that I have those values, I can assign them to create this graph.scatter to list and create a chart. So the x value would be the temperature, the y, or the x value would be the index, the y value would be the current temperature reading during that time. And if I want to display the chart, I just do this. And then right there, I get a chart of the values from that sensor. Of course, I can zoom in and zoom out. If I can highlight certain area if I want to kind of know what the temperature there around that time allows me to. So instead of adding it to a list, I wanted to try this asynchronous stream. Asynchronous stream allows me to return this async enumerable, and this time I'm returning those values. So as it goes through and read the sensor data, it will do this yield return. Grabs the temperature data, it would return it to that stream. And as I call it, it would start adding it to this list, this await for each. So what I'm doing here is I'm doing await for each. For this one, it would delay after 1 second and it would return back. And as I do that, I added this Microsoft.data.analysis. This one allows me to create data frames. So in this one, I want to create a primitive data frame that's date, time, and then double. And as I receive the temperature data here, and it would return back to, I would append the values that I got from that result, from that value, and I'm going to update also the display. So let's see, let's run that. So I got a nuget package, Microsoft.data analysis. It's downloading that. And then it would add those as it gets received, it adds it to that these columns. And once it's done, wait a few minutes, a few seconds. I think I specified 15 times. See, as I receive it, I put the date stamp and add it to this column, data frame column. So if I want to kind of combine those columns together, I can specify, okay, I want to create a data frame. And I want to specify date, times, and far and height. Let's see if that one would work. Of course, it's data frame. And so if I want to display it, boom. That's kind of confusing. It's like all these mapping from all these different numbers, right? But it looks like it's there. It has dates and it has those values. So I found this where you can register a formatter to the data frame so that it would list. So what it's doing here is that it takes the first 5 items of your list, format it to display it properly, like in a table. So it does not read the whole data frame contents, but it just lists the first 5 and displays it properly. So now every time I call df, or every time I call that data frame, it would display it properly. So now I know, every second that I receive the temperature data, I have a reading. It's on my data frame. Say if I want to take the first 2 items, I can run this, and so I have the first 2 items of the first 2 rows. If I want to count the total number of rows, right? df.rows, is that count? And now there's 15 of them, although we only displayed the first 5. So this one, I want to create a Celsius column. But I want to clone it and assign it to a different one, the different data frame. and I want to insert this Celsius column to my new data frame. So notice that I still have the index, I still have date times, the Fahrenheit, and then of course the Celsius, it does not have any values. So this one describes what are the values out there, what data the data type is, and notice the Celsius column does not have any data in it. And if I want to fill it with zeros, I can do that. So we went through all 15 of them, although it's displaying the first 5 here. So now there's 15 items on my Celsius column. If I want to grab the first row, right, I can do that and it'll give me the values. Okay, this next one, I want to I want to fill in the Celsius column with a calculated value. So Fahrenheit minus 32 times 5/9. So this is just the conversion. It kind of reminds me of Excel. You know, those formulas, and then it would calculate it for you. And just like that, it went through all the items on the data frame. This one, if I want to calculate the mean, I can easily calculate it using this. And if I want to chart it, I can do that using this graph.scatter, specify the columns, X and Y, and it would plot it for me. So this is the converted value from our calculation. So for this next one, I only want to read the temperature data, but throw away anything that's greater than I only want to keep the last 10 items on my my list. Anything beyond that, I throw away. So it's the same way, it's just a loop using that sensat. Delay 500 millisecond. So this next code allows me to be able to run a JavaScript program or a JavaScript inside this notebook and read data from my C# kernel. The important part here is that piece right here where I can say interactive.c#.getVariable and then the variable name. In this case, I'm interested with the values that I have on my temperature data, and I want to import it to my JavaScript. What this one is doing is it's importing the D3.js library to be able to create visualization, and it's doing some CSS magic, I guess, or SVG magic. But what I'm interested in, since I have my values here, so this set interval, after 1 second it would update, and what it will do is it would read that temperature data, it would display them, and I think it's better when I show it to you guys. So I have this SVG, so I can specify, hey, HTML, I have this SVG, and I can pick this SVG data plot, and pass it to my JavaScript program and pass the name of the C# variable that it can read. And so it kind of displays it here. So it kind of built that chart for me. So let's see if I call this read temperature data now, right? This method right here. Once I call it, it should technically update these graph. Let's see if it'll do. Depending on the values, because I specify here the value would be 85 to 86. But let's see, let's start with just 2 items. So it's ranging from 100, so it won't display it here. So let me modify it real quick. So it's about 100 to 101, 2. So, hold on a second. Let's modify that axis. 100 to 102. So let me rerun it again and recreate that chart. So you notice that it's blinking right there because every second it's reading the temp data list to get its update. So let me try and run this 20 times now. And as it receives the data, it's updating this chart. Of course, the temperature in here is about the same. So notice that on my temp data, there's only 11 items, even though I ran it 20 times. So it's ignoring all the rest and just plotting the last, 11 items on my list. Cool. Okay, so for this next one, I want to read the temperature, but I want to specify a condition. So if the temperature is more than a certain, degree, I would alert. What I'm doing here is I am changing that LED matrix to fill the color with red, setting up as an alert. So what I'm going to do here is I'll make sure we'll be able to see that when it runs. Scroll down a little bit on here. So I'm going to call these read temp condition. We'll do it 50 times. And let's see if it'll be more than 102. If it's more than 102, it should alert us. It might not be going to be more than 102. It's like about 106. Let me see if I can stop that. Oh, now it's shut down. Application is shutting down. Huh. Let's see if it'll run. 100.8. Okay, here's what happened. Looks like it now it will error out because it does not exist. So let me try to see if I can rerun this part. Because when I click the stop button, it actually it actually stopped the kernel from running and restarted it. So what I typically do there is I can restart the kernel and rerun all the cells. So just to demo that, hey, you can go back from the beginning. It will start from here. It would rerun each one of the same commands again. But it would rerun it as it goes. Okay, while we're waiting on that, I'm gonna move forward on this and come back to it. I have another demo that I can show. So on this one, which is on this anomaly detection, so what I'm gonna do is same way. I will import the GPIO and the IoT device bindings. This units net allows me to do the conversion, or yeah, however it reads it. So this one changes that LED matrix to black. Let me see if I can say green here. Still run. There you go, it's green. Change it to red. Yeah, now it's red. It's too bright, so I'm gonna change it to black. Okay. So this one would allow me to read the same Fahrenheit. Read the sense hat, doing asynchronous streams. And adding it to the list. But the only difference, what I'm doing here, as I do this await for each, is I want to round out the time, because I wanted to look like this, where it's every minute. So even though, you know, it's harder to time its exact millisecond or exact minute, right? So I'm using it to just round it up to the nearest minute and whatever value that I got from my sensor. So it'll grab all that for me. I already ran this because it's, you know, it takes 15 minutes to run. So after I run that, I have these anomaly detector, another nuget package. If you're not familiar with cognitive services anomaly detector, it's a way for us to be able to detect if the next data, or if parts of your data is anomalous or not. In this case, this is a time series data, and I wanted to know if there's an anomaly from that data set. So think about it like, you know, a number that's out of whack. It's not out of normal, right? So that means it's anomaly. It's anomalous. So this anomaly detector would identify patterns and it's using machine learning. And the good thing about cognitive services is it allows us to be able to, as developers that does not have machine learning background, allows us to call these API, pass in our data set, and it would build the algorithm for us and automatically detect and find patterns based from the data we sent to. So we use this anomaly detector package. So this get series, in order to call the API, I need to have these request format. I specify, okay, my data set is per minute, right? And based from that reading, build this request. And then this one calls the API, this anomaly detector client, to detect if the last item on my request is anomalous or not. And if this one would return true. If it's anomalous, it would return false if it's not anomalous. So I would read. So in this one, in order to use the API, you need two things. You need an endpoint and key value. You have to sign up in Azure portal to create an anomaly detector. It will give you a key and an endpoint to connect to. So like in this case, I'm reading it into a JSON, this config.json, and then just assigning this endpoint and key. Let's see if I can run these. So this one creates the client, you specify the key, and you specify the endpoint. And then in this case, what I'm doing is I'm listing the list of all the temperatures, but I'm tricking this because, you know, on the last item, I'm adding 200, so it'll be out of whack, right? Out of the ordinary, so it'll get detected as anomaly. So I pass in the list of temperatures, and now I have a request. I can call this last detect sample async, and then if it's anomalous, it would fill this with red. Fill the sensor, and not the sensor, but this LED matrix to set it out to red. So let's see if I can run it again. See how it did turn red, because this is my data set. The last item was 200. It's out of the ordinary, right? And so since that's out of the ordinary, the API would return, hey, it's anomalous. Let's set it to true, and then set the trigger to red, and set that sensor to red. Of course, that's too bright. It's hurting my eyes. I'm gonna fill it and set the color to black. Cool. All right, let's go back to the presentation. Let's just summarize what actually happened, right? What actually happened is I installed .NET Core in Raspberry Pi, right? Runs on an ARM processor. It is on Linux, right? I installed, and we ran Jupyter Notebook inside Raspberry Pi. We installed PowerShell inside the Raspberry Pi, and also the .NET Interactive. We created our program all in C# in the browser, doing interactive stuff, and be able to create charts and control an IoT device all in the browser. So if you're interested in learning more about my presentation, here is the link to the presentation materials. And if you're interested in learning more about me, I'm a lead software engineer at Spacey. I'm a Microsoft MVP. The best way to contact me is through LinkedIn or Twitter. And I appreciate your time geeking out about Jupyter Notebooks, .NET, and C# and all that. Have a good day. Thank you. That is my goal today, to make .NET cool again. If you think it's cool, give me a thumbs up. I am open for questions. Appreciate it.